Hello and welcome to yet another episode of Nil Dot Talks with AstronEra. I am Kunal and today we have with us Pallavi, and Pallavi is a molecular astrophysicist.
Yeah.
And that's an interesting field. I am hearing it for the first time.
Yeah.
So would you like to introduce yourself and tell people what your field is all about?
Yeah, okay. So, molecular astrophysics is a blend of chemistry and physics. So, like, we study chemistry in outer space. It's a very niche field, like, not many people work on it. And yeah, my long term goal is to establish it as a bigger field because it's very important to know what's out there and the constitution of it, which physics alone cannot do. So I have a major in physical chemistry and in astronomy, and then I'm a pre-doc fellow with the University of Melbourne.
Okay, so basically you study chemical reactions that happen on planets and
Yeah.
inside stars and
Yeah, and basically in all of the interstellar media.
okay, interesting. So let's start with our first question, Pallavi. This is a question that we ask everyone on our
Yeah.
podcast, and it's a very interesting question that has been put forth by Dr. Neil deGrasse Tyson.
Okay.
He says that the closest relative to human beings is the chimpanzee,
Right.
and we share around 98-99% of our DNA with the chimps. And our intelligence stems from that 1% difference in the DNA, like us combining, like a chimp combining a few things to do sign language, and us building Hubble telescope and launching it into space.
Right.
Stems from that 1% difference.
Hmm.
So he asks, what if tomorrow we find a life form which is 1% different to us the way we are to the chimps?
Yeah.
What would that life form be like, and how would they look, and what would their intelligence level
Oh
be?
my, okay, this is a very exciting question. See, when you say 1% different, it can mean two things: 1% less, or 1% more, or 1% in a whole different
1% more.
right?
Yeah.
In a whole different dimension. Considering they're a 1% better than us, it also comes with the factor that their hunger for knowledge, or their what do you say, their perseverance for it, or the lens that they would go for it is presumably stronger than ours is, right? So they might come with their like the huge ocean of knowledge that they have, while at the same time the same levels of I don't want to be pessimistic, but the greed and selfishness and the hunger that us humans come with. But statistically and scientifically speaking, I would like to add a little bit to this. We are more likely to find the life form or extraterrestrial life form that is in the form of insects or locusts or spider-like, because if you look at Earth, you see that insects and stuff, they form 30 to 40% of our whole biomass, right? There
Right.
are so many species and so much of population. To think from that perspective, humans are very small, right? So I feel like the aliens, so-called, let's call them right now,
Yeah.
that we will find in outer space are most probably going to be of the insect type, of the arthropoda type, and not those little cute green alien men that we see
in movies.
And-
Yeah.
right. So that's an important point to consider.
But like, if they're like 1% more intelligent than us,
Yeah.
like even these insects, what do you think they'll be capable of doing?
Can you imagine the armies they would bring forth? Have you seen ants work
Yeah.
together? They're so strong and so determined, and so together it might be a little bit dangerous for us.
Or do you think these insects would be capable of interstellar travel? Like, since
Definitely, yeah. Because see, it depends on how much evolution they've gone through. We call ourselves to be sitting at the peak of evolution, not because of we stand upright and do all of those things. It's just because of our intelligence.
right.
So if these species as well have gotten the time to evolve to become to become intelligent species, then they would be very much capable of doing what we plan to do in outer space, right? So yeah,
Yeah. So since you are a chemist, should I call you a chemist?
you can.
Yeah. Okay. So since you are a chemist, I would like to ask you that if we talk about an element like carbon.
Right.
Okay, so since you are a chemist, I would like to ask you that if we look at an element like carbon,
Yeah.
and carbon has like 4 free electrons in its orbit.
Right.
And we assume that any life we find on an exoplanet will be a carbon-based life form which will be
Right.
dependent on water. But what if we take carbon out of the equation? What if it is like a silicon-based life form? What would that life form be like?
Right. So the first thing to consider is that we know life only when it is based with carbon. So when we look outside to when we try to find life in outer space, it's easier for humans to look for carbon-based life because that's what we've seen for millions of years, right? It would be much easier because per se the life. Let's assume Venus, right? Venus has a lot of sulfur in it. And if we consider that there might be sulfur-based life forms, we would have to completely change our approach as to how we look at these life forms, how we break them down. So when we break down a carbon-based life form such as ours, we break it into, per se, amino acids, fatty acids, nucleotides, and they all come together to form a cell, which percolates life, or which stems life into its form. So the reason why we look for or take the carbon-based approach is for the simplicity of it and nothing else. And because we have the equipment to do so.
Right.
And the avenues that you talked about of other element-based life forms is pretty much in the question and in research. It's just that it's very difficult to do, right?
Difficult to do what?
It's very difficult to find this life.
Okay.
To break it down to what are the main components, what does it do? Per se, we know that amino acids in carbon-based life forms like ours, amino acids will form proteins, right? Fatty acids will form lipids, nucleotides will form DNA and RNA. But how do you break down a life form that is not carbon-based, right? So it's going to take a long time.
Yeah.
And
but do you think such a life form would exist without carbon-based?
Yeah, definitely. See, even on Earth, we've seen. So the life on Earth, as I would say, it's very historical. It's been there for millions of years, and there are so many, tiny amoeba and bacteria that were left unseen, which were not carbon-based at all. But there is no means to go back and trace their steps because, like I said, it's difficult to take that approach from the chemical point of view or from the analytical point of view to break it down, right? That's the only reason.
Yeah, pretty interesting. So Pallavi, when I was in school, we had, when I saw the periodic table of elements for the first time, we had around 116 elements back then. Now we have 118, two more elements that have been added. So do you think there are more elements we can explore, and there's a 119th element out there which we have not yet seen, and what would this element be like, and how does this contribute to this life form we are talking about?
So the thing is, the elements that we find and classify in the whole periodic table, we see a pattern that more and more, as the mass of your base element or the atom, let's talk about that, as it increases, it becomes more and more radioactive. And because it's more and more radioactive, it's difficult to trace them because it's going to kill you, right? So on Earth as well, there are so many elements that are yet to be discovered because first, we don't have the chemical or analytical methods to analyze them. Second, they're radioactive and extremely dangerous. And third, when we talk about the outer space perspective, there are so many parts of outer space that we cannot reach. Our telescopes can reach them, but our chemists cannot. So till a satellite or till a space probe brings you a sample, brings a sample to a chemist like me, and then we analyze it through our methods, and not the methods that we don't know yet, then we cannot figure it out. But then I strongly believe that there are many more elements out there.
Do you think that these 1% better species know more elements than we know?
They would probably know different elements than more elements. Like I said, more higher atomic mass, it goes towards the radioactive side. These species can very well be radioactive and dangerous to us, right? So yeah, that is a perspective. Another thing is that, do you guys know about carbon-12? So carbon-12 is the carbon that is available on Earth. The mass of this one carbon atom that we have on Earth is carbon-12. But all of the samples that we've found in outer space, they all have carbon 13 or carbon 14. They do not have carbon 12. That is how we classify between carbon that is present here or outside.
Right.
So they can very much be forming their life forms with this carbon 13 or 14, and with just one extra marker in their carbon, the life forms can be completely different.
But what's the difference, like carbon 13 and carbon 12? Like, is it like heavier? Or?
Yeah, carbon 13 is heavier than carbon 12,
Okay.
and it is not easily found on Earth.
Right.
And not in our bodies or any species alive on Earth.
Right.
So what is your take on we are made up of star stuff, famous quote of Carl Sagan?
Oh yeah, we are, because you see, I study a lot of my study goes to, how elements are formed in outer space. That's the first thing that is taught to us and the first thing that we study in my field. So, I've studied how hydrogen existed for a long time, and then helium came in, like two hydrogens reacted to form helium, and then more and more and more elements just kept coming in, and those elements are present in our bodies. So we're not technically made of star dust, but I feel like we're made of star elements.
Right.
The elements that were formed in stars and are now somehow making up our bodies, which is very interesting.
This is like a question we ask everyone. We try to connect their field with astronomy, and this is very obvious. Like molecular astrophysics it is directly connected to astronomy. But if I were to ask you to find a connection between these two topics, like how would you find it?
A connection between?
Astronomy and molecular astrophysics.
Oh, okay. So I started off my career with chemistry, and I was always like extremely into astronomy and space, and not very good at physics. So when I started studying more and more astronomy, I realized that till we figure out what stuff is made of, we cannot analyze that stuff, or we cannot find out what the stuff is made of or what it does. So yeah, chemistry is a very essential part of astronomy, which is why I took it up. And it's like a junction between biology and physics, because this chemistry is going to tell you what stuff is made of, and that in turn leads to the biology of it, how these chemical elements or compounds can come together to form a life form, which is the ultimate goal, right, in astronomy, to find extraterrestrial life, basically. Right. So I feel like this 1% intelligent species that we're talking about, I'm sure they would connect the bridge between chemistry and biology that is difficult for us to go through to figure out how life comes into existence, because long ago in the 1800s and stuff, people knew chemistry and people knew biology, but the bridge between them was what they called the divine, because they couldn't understand how they're coming together to form
a life form
that is talking, that's sitting, and that's fully functional, right? So it's if they could teach us, I would be very glad.
But since you talked about this life form evolving, and I would like to talk a little bit about consciousness. And do you think there's a chemistry behind consciousness? Like, how does consciousness come into being? Is it just chemistry, or is it something else?
It's definitely chemistry. It has everything to do with, again, the less of a bridge between chemistry and biology, more of like a binding between them, right? So your consciousness comes from the motor part of your brain, which is fueled by neurons, which work on electric signals, which is again chemistry.
Right. So there's there's nothing magical about consciousness. It's just chemistry.
I can't say that. My supervisors would be pissed, but no, for real, it's all science.
Okay, that is very interesting, Pallavi. And now we are moving towards the last part of our video, and I have a small surprise for you.
Yeah.
It's a rapid fire round. Okay. I'll be asking you a few questions.
I learned that in high school.
I'll be giving you 3 options, and you're supposed to pick one.
Right.
Okay? Alright, so here we go. Okay. So the first question is, which one of these elements do you think would be the most important one to sustain extraterrestrial life? A. Hydrogen. B. Carbon. C. Oxygen.
Oh my! To find out another path from that, all of these are very important to sustain life as we know it. Without one of these elements, our life forms would collapse. But if we talk about the general abundance, hydrogen is abundant in space more than any other element is. So I would say hydrogen.
The most important one. Okay. If you had a chance to live your life as one of these fictional characters, which character would you choose? A. Walter White from Breaking Bad. B. Dr. Ryan Stone, which is Sandra Bullock from Gravity.
Yeah.
C. Joseph Cooper, which is Matthew McConaughey from Interstellar.
I would say all three of them.
No,
but,
you
but
have to
if
choose
I,
one.
But if I kind of, go from a monetary perspective, it's Walter White.
Okay, yeah, interesting. Which one of these pseudosciences do you hate the most?
Oh my god, I would have loved this. Yeah.
A. Astrology. B. Alchemy. C. Numerology.
Oh, astrology definitely, because alchemy
Confuses a lot of things.
Yeah, astrology constitutes of a lot of things, and I am not afraid to say that I
Yeah.
do not support it at
Yeah.
all, because I couldn't find a basis for it. Not like I wasn't
Right.
positive.
It's directly connected with us, like not as much as numerology or alchemy.
Yeah, and alchemy, if alchemy did not exist, we wouldn't be here with chemistry, because earlier people,
Yeah.
people in the medieval ages, thought alchemy was a concept which led to chemistry. And
Right.
numerology, I cannot say anything about it.
Okay,
Yeah.
okay. Third one. If you had the chance to dissect one of these subatomic particles, which one would you choose to dissect?
Yeah.
A. Quarks. B. Leptons. C. Bosons.
Probably quarks.
Quarks. You want to go in the depth of matter, like
Definitely, yeah. Would probably get us closer to the existence of dark matter, which is a huge
Mystery.
question on all of our faces right now.
Right. Interesting. If you had the chance to buy one of these things for your research, which one would you buy? A particle accelerator. B. An electron microscope. C. The most powerful space telescope.
B and C. I mean, I have an electron microscope, but I want a better one.
Okay.
And a space telescope would be just the thing to connect.
You wouldn't go for a particle accelerator?
Particle accelerator has more or less to do with breaking down a particle itself and radiation and
Right,
stuff, which I do specialize in, but not as much as I specialize in amino acids and searching for them in outer space. Yeah.
Okay. What would be the first thing you would do if you encounter an alien? A. Study its chemical composition. B. Greet him or her with a hug if that's possible. And C. Say have a nice day and run for your life.
First. Because I cannot run for my life.
Okay.
I am a researcher right in this field.
Right.
And I wouldn't want to hug them, because what if they're radioactive?
right. So you'll study the chemical composition.
Definitely. That's what I do for a
Distance
living.
Interesting. This is the second last question. If you had a chance to lead one of these organizations, which one would you lead? A. ISRO. B. NASA. C. SpaceX.
Big no to SpaceX, won't describe. But then I would definitely like to work with ISRO, and which is one of my goals, to work with them short term. Not because of patriotism, it is a question, or it is like a concern, but also because all the greatest minds that have inspired me over the years,
Are from ISRO.
Are from ISRO, who gave up huge offers from NASA or from other ESU or other organizations to work for ISRO. They wanted the country to get better, which is why I or us have.
But working with NASA would let you research a little more and get you more funds and all of
but
that.
then,
right?
but then it's
as a
more,
scientist, you would flourish a lot in NASA.
I would. But then ISRO would provide me with it would, it's more of like a what do you say, like a homage to pay to Vikram Sarabhai, to Abdul Kalam, to Nambi Narayanan and Homi Bhabha, all of these people who basically shaped science today. To be honest, we wouldn't be where we are if these people did not do what they did. So it's like a dedication thing.
Interesting.
Yeah.
This is the last question, Pallavi. This is not just for you, this is for everyone. If you had a chance to meet Dr. Neil deGrasse Tyson, what would you say? A. Travel to AstronEra's office to do a Nil Dot Talk. B. Get AstronEra people to come wherever you are to do a Nil Dot Talk. Or C. Do a Nil Dot Talk with AstronEra people over a video call.
B. Because I would ask him to take all of us to Hayden Planetarium. Like, please organize a picnic. Please let me go.
Hayden Planetarium. I haven't heard of it. Like, can you?
Neil deGrasse Tyson was the chairman of Hayden Planetarium. So he basically what is the term for it? He basically articulated the whole space. That place is his second home. So it would be more like a going to a shrine thing for all of
Right.
us, I believe. So I would be so glad if he ever notices us or invites us there.
Yeah. Pallavi, it was so wonderful to have you over here,
Thank you
and
for
we are
inviting
ending this
me.
video over here. Thank you guys for watching this video. If you like this video, please comment, share, like and subscribe, and see you in the next one. Clear skies.